So I'm going to I won't talk with this title slide too much. You all know the title. We're working at MIT to try to deliver, so we have a site license for Mathematica, and we want students to use Mathematica to program and learn engineering. So that's, we're not trying to do anything other than that. We are sort of forming a group, a cooperative, I would call it. It's not a entity other than a cooperative of a bunch of people. There is a website, codeseal.org. If you happen to be interested in getting involved, go to it. There's a little form. Give us your contact information and how you'd like to get involved. There's opportunities for students and professors. We like the acronym. We think it stands for Code, Science, Engineering, and Learning. We think we're very clever sometimes. All right, so for this talk, no grumpy cats. No, this is like a service for the professors who taught me Mathematica, who helped me get a PhD, who got me into Wolfram where I worked for a few years, who have established me, and I want to give back to those people. I have great love and admiration for the professors that helped me, and I want to make sure they get to do the things that they do well, which is deliver awesome curriculum. So join, participate if you want, but no grumpy cats. Okay, I forgot to do this input thing, dang. All right, so I was supposed to do this ahead of time. Yes, so the two people who are leading this, many of you know my smiling friend, Craig Carter. He's at MIT, got a Wolfram Innovator Award in 2012, big lover of Mathematica and all things Wolfram. And then me, I did a PhD in physics, did everything in Mathematica, learned it, loved it, and just went with it. We right now have some educators at different universities who are developing curriculum and are very interested in the design of the interface that I'll show you later in the talk. We are looking to add names to this list, so if you're interested, let me know, and I will let you know how to get involved. We have some actual designers, so I am not a designer by trade. I don't know what I am by trade, but we have some people with actual visual design skills and UX skills helping tell us what is most effective and what's not. There's plenty of room for input at this point. We're very rapidly developing right now, so if you have ideas, let me know, and I can build them in. We have some educational researchers. Janet is at MIT and studies online education and STEM curriculum, and it's a big part of what I want to do. I think educational researchers need to be integrally involved in any kind of education project. They have skills that we don't. And then there's lots of awesome students who have seen what we're doing and said, oh my gosh, I want to help make that thing into a thing. And so yeah, if you have students and other types of ambassador roles that you would like to get people involved, please let me know. All right, so to the main point. Sorry, that side of the room, I don't have a laser pointer, but I'm going to do it over here. So this is what we're building. This is the vision. We have a teacher sitting in the center. They write curriculum. We all have Mathematica notebooks with lots of awesome curriculum. There's a huge untapped resource, which is professors across the world who have written Mathematica notebooks with curriculum. And what we used to do is just send those notebooks and get them back, and that was great, but I think that we can do something a little bit better. So we have a publication platform that takes a notebook, turns it into something, yikes, turns it into something a little bit different. It's like a notebook plus. You send that to the student, who can be of any age. They fill it out, complete the modules, send it back. Because we've built this thing to collect data on everything as well as, so their interactions and all of their coding attempts, we're collecting data on all of that. So we have an automated analysis system that can, interpret everything that's inside the notebook, send you back a report as a professor. You also get back the actual content that the student did. So you can grade it yourself if you want, but we supplement it. Then you can use that to improve your curriculum. But when we grade it, we also, if you choose to give us permission, we share some anonymous data into an educational data repository. where educational researchers can come in and study your curriculum and how effective it is. They can give that information back to you through the analysis system. So if you have a cell and you're like, I'm not sure if this one's super effective, flag it. It goes out, a researcher, does researchy things, sends you back a thing and says, 50% of your students did better when they had this, so it does seem to be improving something. Then you can use that to improve your curriculum. You can also publish your curriculum, if you choose, out onto the web so that all of the world can have access to it, and we can collect data on usage from students around the world who are using your stuff outside of formal learning situations. And yeah, so that's my very arrowful direction that I'm envisioning at this point. So the timeline, because we all have great ideas. What is the actual timeline? Phase 1 is in progress. We're building the notebook into Notebook++ system. That's very actively being developed. It's been my side project all summer long, and I think it's getting somewhere, and I'll show you what it looks like in a little bit. Phase 2, then once we have this interface that we think is actually effective and well designed, then we're going to start having people openly publish curriculum, and then we'll create that curriculum repository for the world to access. And stage 3 is then opening up, once a bunch of students have used your curriculum, opening up the data from it so that educational researchers can come in and give you feedback and learn about what's effective and what's not. So first thing we're going to look at is the curriculum framework, I would call it. It's Notebook to Notebook++. And before I show you the actual framework, I want to, this flip view in the notebook, it's amazing, but sometimes when you click it, it resizes, so it's going to be a little bit flashy. That's not on purpose. So the main idea is we have these lectures that we give out to students. We give them a notebook. We want them to do some work, we want them to take some notes, and then we want them to have something that they understand at the end. So the interface that I'm going to show has 3 main parts. There's the lecture stuff that you've provided, there's a workbook, and then there's the lecture and notes. Your content goes in there, student does work in there, and they end up building this nice personalized textbook, which is a Mathematica notebook with code and annotations and whatever they've wanted to add to it, plus your stuff. This is kind of the philosophy behind this type of interface and the workflow that we imagine, although it's sort of extensible and you don't have to use it this way. There's 4 modes of interacting with this thing. So if you give a student content that you just want them to read, like, read it, play with some code, interact with it, manipulate, that's one mode of interaction. So you have your text, code, and interactives up there. They can take notes and do code explorations down in the second pane. And that's one mode of interaction. The next mode is you say, hey, cool, now I've shown you how to do something, try something for yourself. So you're asking them to try something. You give them a little challenge. They can sit down in the workbook and try to work out what their solution is. And they have access to all the previous content that's already been shown. So we're sequentially giving the lecture materials like 1 slide at a time, essentially. Then, so you've given them some materials. You've asked them to try to solve something. Maybe they solved it, maybe they didn't. Either way, right now is the time to intervene and say, okay, cool. You tried a solution. I also have a solution. It's not the only solution, but here's how I would have solved it. So they don't need to be doing work. You're just wanting them to kind of watch what you're doing. They can open up the workbook if they want to and work in it, but they don't have to. They don't need to be looking at previous materials, but they can. And then, of course, we want some kind of assessment. So when you give them a quiz, I think they should have access to a work area so they can solve problems in Mathematica. They should have access to the previous content. We will add a flag if you want there to be a quiz where they don't have access to previous content for whatever reason. We can add that. I think they should have it, but that's just a personal philosophy. And hopefully the educational researchers will tell us whether or not it's a good one. Yeah, so here's the kind of the overview of the learning cycle. You have them interact with some stuff, reading content. Then you have them try something. Try to solve something similar to what I just showed you how to do. Then you show them how you would have solved that thing that you asked them to try. Then you quiz them to make sure that they learned something. And then you rinse and repeat with different content. All right, so now is the big moment. Hopefully everything works. All right, so I have written a notebook and built it into this interface. Right now it looks like a notebook, which is fine with a little doc cell. This is what you send to the student. So now I'm a student interacting with this system. I have this notebook. Okay, cool, let's get started with some content. It's a very powerful button that went up in the upper left corner. All right, so now we have the interface. And I won't go through all the details, but here's some example in the real world. This is curriculum that Craig has put together over the years. So, all right, we want to learn about the Leonard-Jones potential, which has to do with, atoms inside of a solid. Okay, cool, so we give them some formula. This is, it's a textbook, fine. All right, power of Mathematica. Now you can show them something dynamic that they can look at and say, oh, all right, interesting. You can do some more. All right, so let's look at what if the energy of this particle in a Leonard-Jones potential is high, then it's not just going to oscillate right in the minimum. It's going to start doing some interesting things like come really close to the center and then shoot back out. And that's not a symmetric process, which is a nice little thing. So now you get to access all of the stuff that you know is really powerful with Mathematica. This is just a notebook, that anything you want to put in there, you can put in there. So here we're taking, all of these notes from the teacher, sticking them into the previous page. All right, now we want to, this isn't just about teaching kids material science. This is about teaching them a required literacy in modern science, which is programming. So now we have some programming going on. So all right, so how do we actually do some calculations? Now they can click and evaluate the cells. They can also, we give them a little button, because not everybody, when it's their first time seeing Mathematica, gets the whole shift enter thing. All right, I'm bored. I want to skip it. Oh no, of course I can't, because you have to you have to evaluate all the cells, fine. Okay, all right, this is calculations. Ooh, pretty graph, all right. So I want to play with this as a student. I'm going to send this down to my area. Oh, all right, I need this to be a little bit bigger. All right, now I can kind of play with this. Interesting, so what does it look like out here? Oh, that's kind of cool. All right. Awesome. Well, I kind of like what I did there. I prefer this, so let me save my scratch pad and say, all right. And now I don't need this anymore because I've saved a version of it, so I can clear my scratch pad. Bring that back down. I don't need it. And now, if I click on this magic button, it has everything that was inside of the scratch pad. So we're storing everything when they're attempting solutions, when they're taking notes. They have the option to store that in the system right as they're moving through it. At some point, we'll make that editable so that you can change this kind of in-place button that will launch the notebook. So then you can interact with that notebook right inside the system and save it back down into it. You can also say, this is a notebook, so you can take notes. Oh, interesting. Interesting things. All right. So now I'm a student taking notes, annotating this notebook on the fly in a nice kind of designed environment. Great, so I'm going to take all of my stuff, shove it on over into there, including my notes and that notebook. So now this button still has all of this content, which is also great for educational research. If you're studying programming education, you want to see their coding process. You want to see their attempts and figure out if they're getting more sophisticated in their coding techniques. All right, so now it's a new mode. All right, so now I need to try something. approximate the force, find a linear approximation for the force. I am not going to try to do that on the fly because I'm not so clever, but all right, so I tried something. 4 is definitely, I don't think that's the right answer, but all right, I don't even know. I tried something, and we will add a stopgap in there so they have to do some interactions before they can progress through the challenge. All right, so now I tried that thing. Now I can see the teacher's solution. Got some good feedback yesterday that it might be nice to show a preview of the whole solution and then walk them through step by step, but right now it just goes through step by step. So this is, I'm a professor and this is what I want to do. Oh, I have to evaluate that cell before I can progress. I think that's a good thing, but I imagine students will go, oh, me. All right. So it's something to force their attention to be where you want it to be, which is, hey, here's some steps. Here's the things that I tried. Don't just glance over this thing and think that you have it. At least put your eyes in this direction. Cool. So then I'll save the teacher's solution. All right, and the quiz, it works right now. I think there's a lot fancier things we can do with some stuff that's coming in Mathematica. But for now, I built some little multiple choice quizzes. We'll add some better styling at some point. Oh, all right. Force is not the derivative with respect to time. Oh, with respect to distance. That's nice. And then you can, do short answers. We have a company out in Boston who's very interested in working with professors who want to do short answer questions for science content. So, explain your solution. You can work with them and they can build an automated system that will, kind of use computer augmentation to say, they talked about these 3 topics that you said they should talk about, but they didn't really talk about this thing. We may get real-time interactivity at some point. Right now I'm trying to build it so that it's not dependent on the web because I really want this to be published to the web and have a Raspberry Pi version so that somebody in a country who can only get access to a Raspberry Pi or something like that can still have access to all this curriculum. I'm a bit idealistic like that. So yeah, all right. Looks like I finished it. Let me move my, oh no, I can't. Oh, I have to, dang. Always forcing me to do stuff. The stuff I must do. All right. Submit. Thanks for submitting. Finish lesson. Complete lesson. All right. So now I'm a student and I've gone through this whole lesson. And what I have at the end is the same thing that we used to, have them build, but now it's a nice automated process to build that up with some sort of curated interaction. They have a notebook with all of the content that the teacher provided, with the annotations that they provided, with the code that they were trying when they were trying to solve these, problems. All right, cool. 5 minutes left. Good. Yeah, so this is kind of our vision. So here's that thing that I saved, and now I still have a notebook that has all of my code. Very, very useful. This would have been very nice if I was a student. There's also, we're auto-saving the notebook, so even if they're forgetting to save it, we're taking autosave so that we can have a snapshot of what they were doing at what time while they work through this module. All right, so that's the big interface, Notebook++, as I call it. So I'm really excited to hear feedback about that. I have like 3 slides to talk about the publication process, because it's a pain point for me when I've tried to use other systems, which is I'm a teacher, I have 13 years of content, how do I get it out there into the world? I don't want to use that stuff that you wrote. I know my students, I know my classroom, I know my campus. And, you should have the power to do that. And I think that this publication system allows that to happen. So you have a standard Mathematica notebook, standard style sheet, nothing fancy. All you do is add a few annotations. So at the beginning of the section, you tell us if you want them to be reading this content, if you want this to be a challenge that they need to try, if this is a quiz. And that's it. You take the notebooks that you have, you add a few words with a nice colon to let our system know where they are. Then you eventually will come, I always forget to do this input thing. All right. Eventually you come to the website. So this publication thing is only on my system. At some point we will have a web form where you can come upload it. You can choose, if you want, I want to publish this out to the world and I want it to be built so that it can run on a Raspberry Pi. Or I want it to be built on a web version. That's down the road probably because the Mathematica front end's amazing and I'm not afraid to use it. So I'm going to stick with the desktop first and then move to the web because we can all download files from the internet. That's fine. You have access to whether this is going to get published into the curriculum platform where we'll also try to build, maybe a knowledge graph of science if we get enough curriculum. You may or may not use this to study it for educational research. You can, choose your own licenses, all the stuff that you want to do. And all the stuff that I want to do with my stuff, I will say. Cool, yeah. So that's my spiel.